Number one, let's find the slope. Definition of slope is you compare change in y to change in x. So from 5 to -7, is it increasing or decreasing? It is decreasing, so decrease by what? 5 to -7. It's decreased by -12. So the slope is -12 over, what's the change in x? 1 to 3, it's increased by 2. Increased by 2. So if you simplify it, it's going to be -6. This is the answer. And what's the slope for the question B? So 8 to 8, there's no change. 0, 0 change. And what about 3 to 2? It's decreased by 1, so it's -1, -1, and there's nothing divided by -1 is still nothing. 0 is 1. If you graph it, it will look like horizontal line. 0, fun. You remember this. We're going to talk about direct variation. So we're still talking about proportional relationship. And when two quantities like x and y, when they're showing direct variation. So the quantities are varying, right? The quantities are varying, direct variation. When y is equal to ky, so which means all of the points are, if they're proportional, like for example, let's say we have 2 to 1 and we have 4 to 2. So now what we have 1 to 2 and 2 to 4. I said the opposite way, so but you have to read x first, right? X first. And I just compare x and y. I just compare x, all the x's and all the y's. So y to x, the first one, 1 to 2. So I'm going to put this is y and this is x. So I'm going to put 2 over 1. Okay. So you can also use the next point, but I'm going to just use this point and this point later. So I'm going to just do this. And everyone knows how to compare y and x and 2 to 1, right? If I simplify a little bit, it's going to be times by x times by x, because I want to isolate y. These are gone, so now it's going to be 2x. So this tells you that, oh, the relationship between x and y's are, the x and y's are varying directly. So if you use 2 and 4, you're going to get the same result. Y to x, you're going to put y first, so it's going to be 4 over 2. So this is 4 over 2 is going to be 2. So I'm going to multiply by x and x to cancel this out. Y is equal to 2x. So we get the same conclusion, right? So this y is equal to kx is not out of nowhere. This is already, you guys already know how to get to this equation. So if you compare y to x and by using one of the coordinates, one of the points on the line, then you will get to this equation. So this is not something new. So where k is a number and k is not going to be 0. If k is 0, then we don't need to talk about this. And the number k, and you can also say, oh, k, it seems familiar. This guy is from y is equal to mx plus b. What was m? M stands for the number multiplied to x. This number stands for the slope, right? The slope. Please copy it down. And then the number k is also called the constant of proportionality. And this is also slope. We already know k is a slope because k is a number multiplied to x, and this is a slope from the slope-intercept form. All right, so the graph y is equal to kx is a line, It's a line, as you see, with a slope of k, as you see, that passes through the origin. So we already talked about when two quantities are proportional relationship, then they're passing through, the line passed through the 0, 0 origin, right? So through the origin. And if you still don't know where the origin is, you better put a little arrow. So the two quantities that show direct variation are in a proportional relationship. So we already know that. We just learned about like direct variation looks like y is equal to kx. There's no y-intercept. There's no y-intercept, and each show direct variation are in proportional relationship because we already talked about proportional relationship always pass through the 0, right? Even though it's a straight line, if the line looks like this is not proportional relationship. This is a proportional, but this is not proportional. All right, so if you look at the example, we need to decide if x and y show direct variation. We need to prove that. We need to check if the x and y are changing by this equation, and it passed through the origin, remember. All right, 1, -2, 1, -2. Oh, there's no negative, so I'm going to just skip it. 2, 0, 2, 0, 3, 2, 3, 2, and 4, 4. We already know that this is not going to pass through the origin, right? Because origin is right here. So it's not going to be passed through the origin. So it's not direct variation. What about question B? 0, 0, 2, 2, 4, 4, and 6, 6. If you connect the dots, and you see that the line is a straight and the line passed through the origin. So it is a direct variation. Yes and no, because it doesn't pass through the origin. Because direct variation should be a proportional relationship. So if it's not passing through the origin, then it's not a direct variation. All right, I really want you to remember what the direct variation equation looks like. It looks like k is equal to y is equal to kx. There's no y-intercept, so only x and y, and y should be isolated and x should be multiplied by a number. So now we're going to solve for y, because if you look at this, y is isolated. So I'm going to do -1 -1, and y is equal to 2x minus 1. Is it y is equal to kx? Or so can you say this is direct variation? X and y is not directly vary because of this guy. So it's not direct variation. So if I just explain more, then you might say x and y are not varying directly. Question B, solve for y. Also, you isolate y. How do I isolate y? We multiply by 2, multiply by 2. So it will be gone. Y is equal to 2x. So now, is it y is equal to kx form? Yes. So you can say x and y varies directly. Let's practice more by graphing the data. So 0, -2, I'm going to extend it. So -2 should be here, 0, -2, and 1, 1, 2, 4, 3, and 7 is up here. Okay, so when you connect the dots, do you think this line passed through the origin or no? Origin is here, so it's not direct variation.